Good morning, friends. I'm Dr. B. Dhyanish, Associate Professor, Department of Computer Science and Engineering, Hindustan College of Engineering and Technology, Coimbatore. I'm going to take an important topic in data structure, trees. A tree is a finite set of one or more nodes such that there is a specially designated node called root. The remaining nodes are partitioned into n greater than 0 disjoint set T1, T2 up to T of n, where T1, T2, Tn are called a subtree of the root. Let us take this tree as an example. Here, A is the specially designated node that is called a root. B and C are the left and right subtree of A. Similarly, D and E are the left and right subtree of B. And F and G are the left and right subtree of C. A have, let us say in different manner, A have two child, B and C. B have two child, D and E. C have two child, F and G. So we can able to say like this also. Types of binary tree: full binary tree, complete binary tree, left skewed binary tree, and right skewed binary tree. Full binary tree. So a full binary tree is a tree in which every node has 0 or 2 nodes. Let us see the example for this full binary tree. So let us consider this example. So every node has 0 or 2 child, 2 nodes. So E has, there is no left and right subtrees. D have H left subtree and I is a right subtree. So 0 or 2 nodes. So full binary tree is a tree in which every node has 0 or 2 nodes. Next, complete binary tree. A full binary tree is a tree in which every node other than the leaves has 2 children. A complete binary tree is a binary tree in which every level except possibly the last is completely filled. All the nodes are as far left as possible. Let us see the example for complete binary tree. So here every node other than the leaves has two children. So here the leaves are D, E, F, G. These are all the leaf nodes. For the leaf node, don't have any further subtrees. If and the depth are the same. If it is like this, means it is a complete binary tree. And there is another advantage of this complete binary tree. We can able to find how many nodes are in the complete binary tree. The formula is 2 power h plus 1 minus 1, where h is the height of the tree. So here the height is 0. We need to start from 0. So 0, 1 and 2. So 2 power, the height is 2, 2 plus 1 minus 1. So 2 power 3 minus 1. So 2 power 3 is 8. 8 minus 1 is 7. So totally 7 nodes in the complete binary tree. Let me check. 1, 2, 3, 4, 5, 6, 7. So this is a complete binary tree. Left skewed binary tree. These are those skewed binary tree in which all the nodes are having a left child or no child at all. It is a left side dominated tree. All the right children remain as null. If you see this example, A have only left children. There is no right children for A. Similarly, B have only the left children C. There is no right children for B. Similarly, C have, there is no right children. Only there is a left children D. Next one is right skewed binary tree. Right skewed binary tree are those skewed binary tree in which all the nodes are having a right child or no child at all. It is a right side dominated tree. All the left children remain as null. If you look at this diagram, A have only the right children B. B have only the right subtree C. Similarly, C have only the right subtree D. There is no left subtree. Next important topic, tree traversal. The traversal is a process to visit all the nodes of a tree and may print their values too. Because all the nodes are connected via edges, that is called a links. we always start from the root head node. That is, we cannot randomly access a node in a tree. There are three ways which we use to traverse a tree. Let we look one by one. First one, the types of traversal. The first one is in-order traversal, that is LDR. This is a formula. Next one is pre-order traversal, DLR. And last one is post-order traversal, LRD. What is this meaning of LDR, DLR and LRD? So L is a left subtree, left children. D is a root node. R is a right subtree. So this is LDR, DLR and LRD. So what is a in-order traversal? Let me have the algorithm. Traverse the left subtree, then visit the root, then traverse the right subtree. We have the simple formula for this in order. Already we discussed L, D, R. First we need to look at left subtree, that is B. Next we need to travel to root A. Next we need to come back to right subtree C. So our answer is B, left side, then root node A, then right side C. Next we look at the pre-order traversal. Pre-order is visit the root node, next traverse the left subtree, then travel the right subtree. So our formula is root left right. So first we need to visit the root node, then left subtree, then right subtree. So our answer is root node is A, then left subtree is B, and right subtree is C. So next and last traversal is post order. So visit the left subtree, then visit the right subtree and visit the root. So our formula is left, right, then root, that is D. So start from left, B, C and A. So our answer is B, left subtree, C, right subtree and our root node is A, B, C, A. So this is a small example. Let me go for some deep example for this. In order traversal. How to visit this? So our in order traversal formula is left, root and right, LDR. So let me start from the lowest level, last level subtree. So whenever we are going to solve this, we need to solve only in the subtree wise. So this is the first subtree we need to solve. And similarly this level subtree, we need to solve this too first. So if we solve this, what happens? Left H, root E and I. So HEI, and this subtree JGK. Left is J, root is G and right subtree is K. So HEI JGK. Next we need to solve this subtrees. This subtree 1 and this subtrees. So if you solve this subtree, our answer is left is D, root is B and right subtree is HEI. It is converted. Now the right subtree is HEI. And similarly here in the right hand side, left subtree is F, root node is C and right subtree is JGK. Let me look at the answer. Yes, D, B, HEI, F, C, JGK. And finally, we need to solve this subtree. So if you solve this, DBHEI, that is the left subtree, and root node is A, and right subtree is F, C, J, G, K. So this is our answer. Next we go for the pre-order traversal for the same tree. So our pre-order is root, left, right. So again we need to do the same procedure. We need to solve by the subtree wise from the last level. So first we need to solve this subtree. Next this subtree. We need to solve these two subtrees. If we solve this subtree, first root node E. Left subtree is H. Right subtree is I. So E, H, I. And this side root is G. Left subtree is J and right subtree is K. So G, J, K. Let me look at the answer. E, H, I and G, J, K. Next we need to solve this subtrees and this one in the same level. If we solve this subtree, the root is B, left subtree is D and right subtree is E, H, I. So B, D, E, H, I. In the right hand side, C is a root node, left subtree is F and right subtree is G, J, K. So C, F, G, J, K. Let me look at the answer. So B, D, E, H, I and C, F, G, J, K. Now we need to solve this entire tree. So if we solve this entire tree, our answer is root node A, B, D, E, H, I and right subtree is C, F, G, J, K. So A, B, D, E, H, I, C, F, G, J, K. And last we are going to see about the post order traversal. Our post order is left, root, so left, right and root. The same tree. So again we need to start with this subtrees and this subtree. The same procedure, but the formula is different. So left is H, I, right is I, and root node is E. Similarly here, left is J, and right is K, and root node is G. So H, I, E, J, K, G. Let me look at the answer. So H, I, E, and J, K, G. Next we need to solve this subtrees. This one and this one. So left hand side is D. Right hand side is HIE. Root node is B. So D, HIE, B. And for this subtree, left hand side is F. Right hand side is J, K, G. And the root node is C. So F, J, K, G, C. Let's look at the answer. So D, HIE, B, F, J, K, G, C. Now if you solve this thing, the entire tree, you will get D, H, I, E, B, F, J, K, G, C and the root node is A. So this is our final answer. So in this lecture, we've seen some definition of the trees and the types of tree traversal, in-order traversal, pre-order traversal and post-order traversal and some examples of tree traversal. Thank you.